Hello everyone. So today we will continue with the job sequencing, and we are left with one problem, that is processing of n jobs through 3 machines. So for this, here's a problem. We have 3 machines and we have 7 jobs. These are the machines and these are the jobs which are given to us, and we have to find the sequence and the total time it would take to get executed on 3 machines. Before we will start solving this question, we have to check the condition whether we can solve this question on 3 machines or not. How can we check that? So firstly, check the conditions. The conditions is like this. First condition is minimum value of the first column, say the processing time, okay, t here represents the processing time of the first column, 1 represents the first column, if that is greater than or equal to the maximum value of the second column. Okay, if that would get satisfied, well and good. The second condition which we have to check is the minimum value of the third column should be greater than or equal to the maximum value of the second column. That means in both the cases, we have to compare first column with second column and third column with the second column. Okay, either of the conditions should be true. If one condition is true, that means we can solve this question. If both conditions are false, then we cannot solve this question of job processing on 3 machines. So let us check this out for this particular problem. Okay, we will check this whether we can solve this or not. Okay, the first condition is the minimum processing time of the first column, which we can clearly see is 3. Okay, is 3 greater than or equal to the maximum processing time of the second column, which clearly we can see is 5. So the condition is false. Okay, now let us check the second condition. The minimum processing time of the third column is 6, is greater than or equal to the maximum value of second column is 5. Yes, that means one of the condition is true. We can solve this question on 3 machines. Let us proceed. Now what we have to do is we have to first find the sequence and the total time. In order to calculate the total time, we first have to find the sequence so that we can assign the jobs to 3 machines in order to get executed. So first step is finding the sequence. And in order to find the sequence, we have to create an array of 7 jobs, as we have 7 jobs. Okay, and that this is the left side of the array and this is the right side of the array. If the minimum value is from machine A, we write that on the right side of the array. If it is from the second machine, we write that on the left side of the array. But in this case, we are not having only 2 machines, but we have 3 machines. So how can we find the sequence? For that purpose, we have to convert this problem, this 3 machine problem, into the 2 machine problem. Okay, in order to find the sequence. So we will convert this 3 machine problem into the 2 machine problem so that we can solve this. So let us do that. Let us take 2 arbitrary machines, say machine A and machine B. And how many jobs we have? 7 jobs. A, B, C, D, E, F, and G. All the questions have been taken from the book. If you have book, please open that and check this out. Okay, now we took 2 arbitrary machines. Okay, so this is how we convert this 3 machine problem into the 2 machine problem. We take 2 arbitrary machines, A and B. What would be the processing times of these 2 machines? For machine A, the summation of the processing times of machine 1 and 2 will be the processing time for A. Then from machine 2 to 3 will be the processing times for machine B. So let us get started. So 3 plus 4 is 7. So 7 would be here. 6 plus 4 is 10. 8 plus 3 is 11. 7 3 is 10. 7 2 is 9. And 2 5 is 7. 5 and this is 9. This is 16. This is 10 and this is 6. 8 plus 4 is 12. This is 10. This is 10 and this is 15. So these are the processing times for the arbitrary machines. Now we have to find the sequence. After finding the sequence, please always remember, for any question you can have one sequence or you can have multiple sequence. It depends on you which sequence you would like to choose or you would like to take in order to solve the questions. Okay. Clearly I can see that for this particular question we can have multiple sequences. I will design one. If you want to solve this by yourself, once again try to do it by with another sequence. Okay, so you know the procedure. In order to find the sequence, we have to find the minimum processing time or value from machine A and machine B, from the processing times of machine A and B. So the minimum value which I can see is 6. Okay, so it belongs to machine, it is the job number E which belongs to machine B, and clearly we can write job number E on the left side of the array, and this would get cancelled out. After that, the minimum value is this and this. You can take either of the two, depends on you which one you would like to choose. So if I would choose C, that belongs to machine B, so C would get here, this would get cancelled out. Again, if I would choose, the minimum value will be this, and this belongs to machine A. I have to write this on the right side of the array, job number A, and this would get cancelled out. 11, 10, 9, 16, 12, 10, 10, 15. Out of all these, the minimum value is 9, which belongs to machine A. So D would get on the right side of the array, and this would get cancelled out. 11, 10, 12, 10, 10, 15. So 10 clearly is the minimum value, so depends which one you would like to choose. Let us start from here. 10, so B would get here, so 10, F will be here, so we are left with single job, so G would be here. You can create another sequence and solve the same question if you want to. So let us solve this question now. We got our sequence. This is a sequence which we have to follow for 3 machines in order to get executed. So say these are the 3 machines. This is step number 2. And how many jobs we have? We have 7 jobs. Job number A, B, C, D, E, F, and G. We will do this quickly because we have already done this in the last lecture. Now we have to do it in the similar way as we did in the job sequencing part first. So it's in time, the assumptions are same. Okay, so it's in time A0. Oh sorry, I forgot to write the sequence. The sequence which we got is like this: first job A, then job D would get executed, then job G, then F, then B, then C, and lastly job number E would get executed. Okay, so from here we know that job number A would take, now this we don't have to take into consideration, this is only for finding the sequence, forget about this now. Now see, we have to execute job number A on first machine, on second machine, and on third machine, and we know job number A would take 3 hours of processing in order to get executed on machine 1, so it would take 3 hours of processing. After 3 hours of processing, this job would be given to machine 2. That means machine 2 has to wait for how many hours? 3 hours. Then this would take 4 hours of processing in order to get executed on machine M2, when it would be given at the third hour, when it is going to be executed after 4. That means 4 plus 3 is 7. Machine 3 has to wait for how many hours in order to get job A? 7 hours. So 7 hours. Then job A would take 6 hours of processing on machine M3. So when it is going to be executed completely, that means 7 plus 6 is 13. It would get executed at the 13th hour. Similarly, the same procedure would get followed for rest of the jobs. I will do it quickly. Please, you do it as you want to. Now, after completing job A on machine 1, at that time we can assign job D to machine M1 at the third hour. Job D would take 4 hours of processing. 4 plus 3 is 7, and this would get in 7 hours. 7 plus 5 is 12, and this would be given at the 13th hour, because this machine 3 has to no, job number D has to wait for 1 more hour, because this would take 13 hours of processing. 13 plus 11 is 24 hours. Okay, job number G, 7. This is 7, this is 14, so this would be given to 14. 14 plus 3, 14, 15, 16, 17.